Hey everyone, and I will make it short so we can go launch quicker. Yeah. Yeah, basically yeah, for people who doesn't know so much, just give a brief intro. So 3 years ago, we were a storage provider. We're still a storage provider. We have still have about 20 petabyte storage in North America, Canada, and North Carolina. So at that time, when I think it's 4 years ago now, when when the Filecoin mainnet launching. So we make a decision. We split the team, become two teams. One working as storage provider, another one to start research about how to use the stored data. And the part of stored data, we give it a new brand called Swan. So basically what it does is that it's a data market. Then through the data market, we're thinking about how to doing the data, store the hot storage data on top of Filecoin. 1 year later, we decided to start the computing part. We're doing the computing over the data. So then we found that there are lots of solutions, how to store the data models and IPFS, how to archive data on Filecoin storage node, and etc. So this year, we officially started building the smart contract on OP ecosystem. We just recently get about 500,000 token grant from Optizen to do the computing over the data, but we're still using Filecoin as a major storage player. And yeah, so this is what. So we have a challenge, which the very famous challenge is Ethereum is too expensive. So in order to solve the issue, we have to aggregate the data. What we're doing is we have a computing provider stay with storage provider and Filecoin ecosystem. We need to submit the proof. With Filecoin, the proof submission is not costing much at the moment. But if people remember 3 years ago, it was super expensive because too much traffic. The problems still are existing on the Ethereum. So even with Layer 2 as the OP roll-up, it's still not resolved. It decreased the cost about 90%, but it's still quite expensive. So one challenge for us is we need the computing providers works as similar to the storage provider, submit the proof on chain. But it's much faster because when people leasing the GPUs from network, it can be only a few hours, not days. So we kind of like storage providers, you submit the storage proof daily. We need to make it short. So the sampling and the proof submission will reduce to hours. So maybe every 4 hours in the submit proof, and because it's on Ethereum, it becomes super expensive. We needed to find a way to aggregate the proof submission. The way how we're working is we make the computing provider set up a computing account. So it's smart contract based computing account, and you submit the proof with the different data inside. It includes the proof usually is not just, it can be ZK proof, and it can be some AI tasks, for example, store diffusions or some other easy validated computing benchmark jobs. In submission, you need to tell people what is the root, the origin data, what is the origin model, and how to validate it. And all the information is quite large. The one way we think about solve it is we let all the computing providers submission and integrate the data to a blob. But the blob is not the Ethereum blob because the blob is still too expensive. We are using IPFS storage CIDs as blob. So we put the data in the CID blobs, and we submit the CIDs to the smart contract to be on chain. Then it's roll up to the layer 1, and this is how we work. And beyond the saying, we still have our old, not old, but the existing IPFS enhancement backup kit. So the data is on the hosted IPFS. So we have a storage agent doing the auction engine, dispatched to the community server. We still have over 20 storage providers working with us. So we have 2 major nodes, which is owned by us in Canada and the US, and the other nodes have the data on from community. So the data with the IPFS is chunked and dispatched back up to Filecoin node. One day, if we lost the IPFS cluster, we can still recover the data from Filecoin nodes. And in this way, we make this is just a sample of how the CID is looking. So on the left is the data we store on the IPFS with one submit proof. It has CIDs, and if you go into the CIDs, it has all the account address and the token and the source content. It's also like verified parameters and the data line and check code, everything as a block file. So every few hours, it will be published on the IPFS. By using this algorithm, this is how we solve the gas cost. So with the layer 2, it decreases about 90%, but with layer 3, it's almost nothing. So with this structure, we cost less than 0.01 Ethereum, which means the total cost of internet network is only around $30. So currently, we have about 700 computing providers on the network doing submission every day. Anybody knows like how many providers now we have on Filecoin? That's last year. 2,200. That's today's data. So basically, like, we already have about 30% of the provider of Filecoin, but the daily submission fees is around $30. So that is how we are using IPFS and Filecoin as a real case to solve a layer 2 blockchain gas cost issue. Yeah, that's pretty much it. And any questions?
I do have some questions. So your infra, at least in the network, right? I mean, your customer base that you talk about there, the number of SPs using you. Yeah, where are they? Where are they in adjacent to your infrastructure, right? So do you still run these facilities in North America, but you're servicing customers outside of North America?
You are talking about the Filecoin storage?
Yeah.
Yeah, the storage is, let's go back to this table.
This one, yes.
Yeah, so those two are the major nodes, which we can always, for us, we can rely on. But the competing nodes, in case our major nodes falling over, expire, data doesn't exist. And our clients is the computing providers, who, for example, I finish one sampling task, but people, the validator says that you didn't do the job. Then we need the proof, right? Then we check the CIDs to get the proof origin data. We need to put the data doing validation. So basically, we serve the computing providers. So now we have a provider from North America, from Asia, from Europe. So basically, all over the world, they rely on the system to get the data to challenge it. They can file the claim about like, look, we do have the proof submit, and not rewarded because they're also slashing in algorithm implemented as well.
And latency is not a concern here?
You mean the latency of computing?
Yeah.
Latency is not a big concern because with the ARM, large language models, it processing time is about 12 seconds by each token conversation. So latency half a second is acceptable. So usually we test the latency is around 500 milliseconds to 100 milliseconds as an average. And a normal conversation with number 7B is 12 seconds with H100.
From ecosystem participation and dependency, right? So you have your own dev team, you always have, right? Strong group of devs that somewhat rely on Lotus, maybe Curio. Like, how dependent are you on the Lotus changes coming, or have you completely forked everything and just gone down your own path?
Because for us, those new changes doesn't really like change our core business model. So with the latest changes you guys have been performed is something for us good to have. Because what we are using the Filecoin is as a backup layer. So if that's new to us, we can use it. But it doesn't change our core business model at the moment.
Good. Any other questions? And then,
can you explain a little bit more detail, validate proof loop and batch validate proofs? What exactly is going on there?
So the validate proofs is, for example, you have we generate the last time. I think in Brussels, I don't know when. We were implemented sampling and challenge system. So it's using the ZK proof taken from Filecoin. So we're using Filecoin 32 gigabyte, the CC sectors, the computing as a proof. So if you want to prove that you have enough computing power, you need to run the CC sectors, 32 gigabyte CC sectors, I mean the ZK proofs. So now we add more proofs. So because we're bridging the...
How is a Filecoin sealed sector a proof of anything related to compute?
It's just like because the Filecoin ZK proof is something, ZKP is something like hard to reverse engineering, but it's easy, hard to calculation, but easy to prove, to validate. So basically, we just take the part of that code, we're building a sampling pool. So when you're running it, it's so fast to validate. You run several validators. It's more like the recent AVS system. You have different nodes validating if this node doing the job, and also similar to the challenge system, Filecoin has been implemented doing for the slashing. So you have the smart contract connect together with the EVS system. So if you do have something wrong, the slashing is working. Yeah, but we add more and more proofs to it. It includes the AI proofs as well, sampling system. Because with different GPUs, there are different benchmarks can easily validate to finish the job on time. Yeah, the mostly is a different kind of the proofs. For example, the ZK proofs your submissions, the AI jobs. For example, you get stable diffusion jobs and you finish it and you submit the result somewhere else to say like, okay, this is the job details. With the job details, that clear definition about where is the source code and what is the final data and also the claims. So you put it there. We're building another similar Web 2 experience. We have a CRM system behind it. So if we will do, for example, I'm the developer, I'm leasing an instance from you guys, and this instance doesn't finish the work. I can directly stop in the proof with the CID, and we have human interaction to help you to check it if it's need to be refunded or not. So we have a dev console. You can directly submission, and it connect to a ERP system to go through a different process and fast refund. Oh, it's EVM based. So basically, if you have a Filecoin EVM system, you can migrate it to it. It's just the performance and some small glitches, but it can be resolved. No, we don't submit. The jobs itself is submitting to the jobs is stored on IPFS. So IPFS is still the major places to have. So if you go here, you can see the input parameters. So those are the parameters inputted, and this is verified. So what's your verified validations and the task name, and you can also be tracking this. And this is in the IPFS as one blob data, and all those are the accounts. So with this CPU account, committing provider accounts, you can see like all the information, the transaction hashes, everything. So you can always get the records back from IPFS. But those IPFS data back up to the Filecoin. So yeah, so this is basically just something we have done 3 years ago. Now we put everything together, become a huge system.